Let us now move on to the next kind, actually the last kind of organic reaction, that is the elimination reaction. Now, as such, the textbook does not mention this reaction. I have not seen the word elimination reaction in the textbook. I don't think it's there in our textbook. But I have seen that in board papers, questions pertaining to elimination reaction have been asked sometimes. So, although the concept is not as such there in the textbook, it has been asked before, so I don't want to leave it out. Moreover, it's an important question, important concept with regards to your external examinations, your Olympiads, your competitive examinations. So they help you in that perspective, in that respect. So elimination, as the word suggests, it's pretty simple to understand. Elimination means to eliminate, to remove something, right? So basically, it is a kind of reaction in which some particular group of atoms or some particular substance is removed from an organic compound. So the reaction in which an atom or group of atoms is removed from an organic compound. Okay, this is called elimination reaction. Okay, so when we eliminate a particular group of compounds or a particular substance from an organic compound, we say that we are performing an elimination reaction. So I hope that is clear. When we are eliminating a particular substance, when we are eliminating something from an organic compound. Let's take the three kinds of elimination reaction. Now there are types of elimination reactions and we basically have three. Okay, types of elimination reactions. So we are going to basically discuss three of them. Okay, three elimination reactions. First one, dehydration reaction. Dehydration reaction. Second is decarboxylation reaction. Decarboxylation reaction. And the fourth is the third is dehydrohalogenation reaction. So these are the types of elimination reactions. Okay, let's have a look at the meaning. Dehydration meaning removing water, right? When we say we are dehydrated, means we have a lack of water. So dehydration means removal of water. So dehydration reaction means elimination of water. When we are removing water from an organic compound, so elimination of water. Next is decarboxylation reaction. This is elimination of carbon dioxide. Elimination of carbon dioxide. And lastly, we have dehydrohalogenation reaction. You remember in addition reaction, we did hydrohalogenation reaction. So here dehydrohalogenation reaction means removal of hydrogen halide. So elimination of hydrogen halide, HX, denoted by HX, hydrogen halide, hydrogen combined with a halogen. Right? So these are the three kinds of elimination reactions that we have in our course, and I'm going to discuss them bit by bit now. Okay, so let's start with the first one, that is dehydration reaction. So what is the definition of a dehydration reaction? Dehydration reaction is basically a reaction in which water is removed. Water is eliminated from an alcohol. Okay, so it basically is the removal of water from an alcohol, removal of water from an alcohol with the use of an acid or acidic medium as a dehydrating agent. Okay, so Basically, removal of water from an alcohol with the use of an acidic medium as a dehydrating agent. So basically we take an alcohol and then we use a dehydrating agent as a catalyst, and then water is removed from the compound and we get as a result an alkene. So as a result, an alkene is obtained. Okay, so after the removal of H2O, we get one alkene, right? So this is the dehydration reaction. Let's take an example. For example, we have ethanol, C2H5OH. Okay, this is your ethanol. Now, ethanol undergoes dehydration reaction in the presence of conc H2SO4. So, concentrated H2SO4 acts as an acidic medium, and you can see we need an acidic medium, and this conc H2SO4 acts as a dehydrating agent, and then as a result it removes one water from this, that is OH, and then one hydrogen. So as a result we get C2H4, which is what? It is nothing but your ethene, which is a what? Which is an alkene. So ethanol, which is an alcohol, undergoes dehydration reaction in the presence of conc H2SO4 and gives ethene, which is an alkene. Let's take another example. If we have C3, yes, you can say C3, let's take propanol. So we'll take CH3, CH2, CHOH, okay, or CH2OH. So this is your propanol. Okay. So propanol undergoes dehydration reaction in the presence of again a concentrated H2SO4. You can take any acid, but we usually take concentrated H2SO4. And then again it loses OH and it loses one hydrogen. So we get CH3, CH double bond CH2. That is propene. We get propene. Okay, so propanol undergoes dehydration reaction in the presence of conc H2SO4 to give propene, again an alkene. So in this way you can see that a water molecule is lost. You can see, I'll explain it to you with structure also. If you have ethanol, okay, you can do it like this. If you have ethanol, that is CH3, CH2, OH. So you can see that when we are passing, or when we are taking an acidic medium, this HOH together they form H2O. This gets removed, right? This gets removed, and then this bond breaks. This bond breaks. Ultimately, a bond forms here, right? So I hope you understand that. Let's take the example of propanol as well. So we take CH3, then we have CH2, then we have CH2, OH. So again, what do we do? Actually, let's take it like this. Let's take the OH here. It will be easy for me to explain. Now, again, H from one carbon and OH from another carbon. This H2O group is removed, right? Because H plus OH is H2O. So this is removed. Again, this bond breaks, and ultimately, to complete their octet, they form another bond between themselves. So what does it form? CH3, CH, CH2. That is propene. So this is the mechanism of the dehydration reaction, right? I hope that's absolutely clear. This is the dehydration reaction. Removal of water in the presence of an acidic medium from an alcohol to form an alkene. Let's move to the next kind of reaction, that is decarboxylation. Now this is a bit long. Please pay attention to this reaction. This is decarboxylation reaction. Now in decarboxylation reaction, there is removal of carbon dioxide, right? So it is basically the removal of carbon dioxide from a salt, of a carboxylic acid, with the use of soda lime. And soda lime is basically a mixture of calcium oxide and sodium hydroxide, CaO plus NaOH. So soda lime is used to remove carbon dioxide from a salt of a carboxylic acid, okay, to form an alkane. To form an alkane, but there is a condition. To form an alkane with one carbon less. With one carbon less than the original acid. Than the original acid. This is your decarboxylation reaction. Okay, let's take an example to understand it better. Basically, soda lime is used to remove carbon dioxide from the salt of a carboxylic acid, and we as a result get an alkane with one carbon less than the original acid. So let's take the example. For example, I have CH3COOH, that is ethanoic acid. Now, ethanoic acid, okay, it reacts with sodium to give CH3COONA plus H2. So basically we are getting what? Sodium acetate, right? And this is basically your ethanoic acid or acetic acid or acetic acid. And this is your sodium metal. Now, this is the salt of this carboxylic acid, right? Now, when we pass this through soda lime, that is CaO plus NaOH. So when we pass this through soda lime, we get an alkane because it is going to lose carbon dioxide. It is going to lose carbon dioxide. So remember, beta, we're going to lose carbon dioxide. So here, this carbon can go and 2 oxygen will go, right? Along with this, you also lose the sodium. You also lose the sodium because there is a loss of Na2CO3. There is also a loss of Na2CO3. So basically, it loses this, and ultimately you will get, because of this oxygen and all, ultimately you will get an alkane. But the alkane will have one carbon less, as I told you. So how many carbons does this have? Here the number of carbons is 2. So you're going to get an alkane with one carbon less than 2. That is 1 carbon. 2 minus 1 is 1 carbon. So you're going to get an alkane with only 1 carbon. That is methane. So answer is CH4. Now that's understood. Because of the reaction with soda lime, that is CaO plus NaOH, the sodium acetate will lose sodium carbonate, and it will also lose carbon dioxide. Together it will give you CH4, that is methane. That is an alkane with 1 carbon less than the original salt or the original acid. Right? I hope that's absolutely clear. This is what we call decarboxylation reaction. Removal of carbon dioxide from the salt of a carboxylic acid when it passes through soda lime, that is a mixture of calcium oxide and sodium hydroxide, to obtain an alkane which has 1 carbon less than the original acid or original salt of the carboxylic acid. So I hope this example clears it all. Is there any kind of doubt? If there is, please post it in the comment section below. Next, we come to the last kind of elimination reaction that we have, and that is your dehydrohalogenation reaction. Now, as I've told you before, hydrogen halide is hydrohalogenation, the addition of hydrogen halide to an unsaturated hydrocarbon. But dehydrohalogenation is basically the removal of that hydrogen halide. So it is the removal of hydrogen halide, HX. HX denotes hydrogen halide. Removal of hydrogen halide, HX, because X denotes halogens. So hydrogen bonded with the halogen gives hydrogen halide. Removal of hydrogen halide from a hydrocarbon obviously containing a hydrogen halide with the use of aqueous KOH. Okay, with the use of aqueous not aqueous, alcoholic KOH, with the use of alcoholic KOH. So KOH, which is a solution of KOH along with alcohol, some alcohol. Okay, so with the use of alcoholic KOH, we remove hydrogen halide from a hydrocarbon. For example, again, this is elimination of the hydrogen halide group. So for example, you have, let's take CH3, CH2Cl. This is chloroethane. Okay, chloroethane. So if I write this in the structural formula, this will be CH3 or CH2. Again, you can attach a hydrogen here, and then CH2, to which you add, attach a chlorine. So now, when this reacts with, or when this reacts in the presence of alcoholic KOH, at the time this HX will remove. So H along with X, which is here in this case chlorine, which is a halogen. So HCl, this group will be removed. This group will be removed. And as a result, what will you get? You will get CH2, and this bond is going to break. And as a result, to complete octet, there's going to be a bond between these two. So there will be CH2 double bond CH2, which is what? Ethene. Which is ethene. Let's take another example. Suppose you have CH3, CH2, not CH2, suppose you have CH and then Cl, then CH3, which is your 2-chloropropane. 2-chloropropane. So this again reacts with alcoholic KOH, and in the presence of alcoholic KOH, we can write this as, if this is suppose 2, and to this we are attaching a hydrogen, then as I told you, this HCl again will be removed. The HCl is going to go, and ultimately these bonds will break, and to complete the octet, another bond will form. So again, what will we get? CH3, CH, and then double bond CH2, which is what? Propene. Right? So basically, an alkene is formed when a hydrocarbon containing hydrogen halide is passed through alcoholic KOH. It loses that hydrogen halide group and it forms an alkene. So I hope that's absolutely clear. If there is any kind of doubt, it is most welcome in the comment section below. And with this, we are done with the elimination reaction. We have one more reaction left, which I want to include in the organic reactions. That is the esterification reaction. Although it has been mentioned later on as soaps and detergents and then properties of ethanoic acid, but I want to complete it here, just to finish off the reactions. Then after that, we'll be moving on to the properties of ethanol and ethanoic acid. So thank you very much for joining me, and look up to the next video for the esterification reaction. Thank you very much.